Okay, let's talk about polynomial functions. We have standard form and factored form. I know this looks really scary, but I want you to think back to our quadratic functions. Remember, with our quadratic functions, we had standard form, which was ax squared plus bx plus c. And then we had vertex form, which was a times x minus h quantity squared plus k. And remember that we could tell the difference because standard form was just plus and minus our terms, whereas our vertex form had our parentheses. Same thing comes into play with polynomials. If you are in standard form, you have no parentheses, and this is written in descending order for our exponents. So that n is our highest exponent, and it counts down, moving from left to right. With our factored form, we have parentheses. Okay, so you need to be able to tell which form you have for your polynomials to figure out all the different characteristics or all the very cool things about those functions. But before we even get into finding all of those cool things I was just talking about, you have to be able to figure out what a polynomial is. And there's some rules to be part of the polynomial club. And the first rule is you don't talk about polynomial club. No, the first rule is that you cannot have any negative exponents on our variables. So if you have a negative exponent on your variable, you're not a polynomial. You're not part of the polynomial club. You're not going to have any fractional exponents. Fractional exponents get you into radicals, and radical equations and radical functions are not polynomials. And finally, no variables in a denominator. So if you have a fraction, you can't have a variable hanging out in the bottom of the fraction. If you have that, not part of the polynomial club. So our first example, we're going to go through and determine whether or not we have polynomials. And if it's not, we're going to figure out why. Looking at our first example, we have g of x is equal to 13x to the third plus 17x. So let's go through the rules. Does it have a fractional exponent? No. Does it have a negative exponent? No. Does it have a variable in a denominator? No. So it can be part of our polynomial club. Let's look at part B. We have h of x is equal to 17. This is the same thing as saying y is equal to 17. It's a horizontal line if we were to graph it. And I know it doesn't look like much, but if you look at this 17, he doesn't have a fractional exponent on a variable. He doesn't have a negative exponent on a variable. He doesn't have a variable in a denominator. So this guy is a polynomial. Yes, even your integers, the numbers that you're used to, are polynomials. Part C, we have m of x equal to negative 21 x to the 7th minus 3x plus 3/4. Now you may be thinking, wait, this guy has a fraction. That's not a polynomial. You can have a fraction, but there's no variable in the denominator. And because there is no variable in the denominator, and there are no negative exponents or fractional exponents on those variables, this guy is a polynomial. Part D, r of x is equal to 6x to the negative 4 minus 7x. That guy right there. No negative exponents on our variables. Which means that he is not a polynomial. Part E, we have t of x is equal to 4x to the 1/2 minus 4. Again, the issue is in our first term. We have a rule, no fractional exponents. And because he has an exponent that is a fraction, he is not a polynomial. Can't be part of our club if you can't follow the rules. Let's look at the last one. We have p of x is equal to 11 all over x to the 3rd plus 31x minus 121. Again, not following the rules. This guy has a variable in the denominator. And remember, the denominator is the bottom part of the fraction, which means that he is not part of the polynomial club. So when you're looking at all of these, remember to look for fractional exponents on your variables, negative exponents on your variables, and if a variable is hanging out in the denominator of a fraction. If they break any of those rules, they are not part of our polynomial club.